All right, so get ready because today on the deep dive, we're going to make you the star of your next cocktail party.
Oh, is that right?
You'll be dropping knowledge bombs about, get this, molecular gastronomy.
Molecular gastronomy. Now that sounds a little intimidating.
I know, right? But trust me, it's way cooler than it sounds. We're basically talking about the science behind cooking and flavor.
Okay, so like instead of just blindly following recipes, we're going to actually understand why those recipes work.
You got it. Molecular gastronomy is all about understanding those chemical and physical transformations that happen when we cook.
Oh, so that's how you get that perfect sear on a steak or a beautiful golden crust on bread.
Bingo.
It's about the science behind those transformations.
And get this, today we're going to dive into 5 key concepts that'll totally change the way you think about cooking.
5. Okay, lay 'em on me.
Let's kick things off with the Maillard reaction.
The Maillard reaction. All right, I'm listening.
This is a big one, folk. It's what gives us those mouth-watering flavors in things like grilled meats, roasted coffee, and even baked bread.
Oh, okay, I'm starting to get it. So it's not just about like getting grill marks. There's an actual chemical reaction happening.
You got it. So basically, it's a reaction between amino acids and sugars that happens at high temperatures.
And that creates like a bunch of complex flavors.
Hundreds. I mean, we're talking a whole symphony of flavors and aromas happening right there on your steak.
Wow, so next time I'm grilling, I'm going to be thinking about amino acids and sugars having a party.
Now you're getting it. And here's another mind blower. The Maillard reaction isn't just for meat. It's also responsible for the aroma of freshly baked bread, roasted coffee, chocolate, you name it.
Wow, that's amazing. One reaction, so many flavors. Okay, what's next on our list?
Let's move on to caramelization.
Caramelization. Oh, you mean like when you melt sugar until it turns brown and delicious?
Well, it's a bit more nuanced than that.
Oh.
It's actually a series of reactions that breaks down the sugar molecules, creating all sorts of flavors, from sweet and nutty to even a little bitter.
Like the top of a creme brulee?
Exactly. Or those amazing caramelized onions.
Okay, so it's not just making sugar sweeter, it's actually getting new flavors.
And get this, caramelization isn't just limited to sugar.
Wait, really?
Yep, it can happen with other carbohydrates too, like the ones naturally found in onions and other veggies.
So that's why they get that golden brown color and intense flavor when you cook them.
Precisely.
Okay, we've talked about Maillard reaction, we've talked about caramelization. What other molecular gastronomy secrets are you going to let me in on?
Well, how about spherification?
Spherification. What in the world is that?
Have you ever seen those, like, tiny caviar pearls that chefs use?
Oh, yeah, they burst in your mouth with all these crazy flavors.
That's spherification.
No way, but how do they even make those?
Okay, so it involves this magical ingredient called sodium alginate.
Sodium alginate, huh?
You mix it with the liquid you want to encapsulate and then drop it into a calcium bath.
A calcium bath. This is getting interesting.
And then, bam, the calcium reacts with the alginate and forms a thin gel membrane around the liquid, creating a perfect little sphere.
So like a tiny edible balloon.
Exactly. And the best part is, it can be filled with anything. Imagine a caviar pearl that bursts with mango juice or even balsamic vinegar.
Wow, okay. My mind is blown. Spherification, got it. What else is there?
All right, last one for today, emulsification.
Emulsification. Okay, that one sounds kind of familiar.
It's something we do all the time in the kitchen, even if we don't realize it.
Like what?
Think about salad dressings or sauces. Those are emulsions.
So it's like mixing oil and water together.
You got it. But the trick is, you need an emulsifier to keep them from separating.
Oh, like egg yolks and mayonnaise?
Exactly. Or mustard and vinaigrette.
So basically, the emulsifier acts like a peace treaty between the oil and water molecules.
I like that analogy. And the cool thing is, by understanding emulsification, we can control the texture and stability of our sauces and dressing.
Okay, so that's 5 key concepts. Maillard reaction, caramelization, spherification, emulsification. Did I miss any?
You got them all.
And those are all part of molecular gastronomy.
You bet.
Okay, I'm starting to see how this could be pretty useful even for a home cook like me.
I told you it was cool.
All right, so now I know a little bit about what molecular gastronomy is, but how do we actually use this stuff in real life?
Well, that's what we're going to talk about next time. All right, so last time on the deep dive, we got a taste of the science behind our favorite foods.
That's right, we dipped our toes into the fascinating world of molecular gastronomy.
We covered some pretty mind-blowing concepts.
Maillard reaction, caramelization, spherification, emulsification, the whole shebang.
But now let's get down to business.
How do we actually use this stuff in the kitchen?
Let's start with something simple, like searing a steak.
Ah, the perfect steak. Every grill master's dream.
Remember the Maillard reaction?
Amino acids and sugars doing the tango at high heat.
That's the one. So when you sear a steak, you're basically orchestrating that reaction right on the surface of the meat.
creating that beautiful crust and all those incredible aromas.
It's not just about those grill marks, it's about unlocking layers of flavor.
And the beauty of the Maillard reaction is that it's not limited to just meat.
Oh, right, we talked about that.
Roasted veggies, baked bread, coffee, you name it, the Maillard reaction is there working its magic.
It's like the culinary equivalent of a Swiss Army knife.
Absolutely. So versatile. Okay, so we've got the Maillard reaction down. What about caramelization?
Ah, caramelization, my weakness.
Those golden brown onions, the sweet, crunchy top of a creme brulee.
It's pure magic.
But there's science behind that magic, right?
You bet. When you heat sugar, it goes through a series of reactions, breaking down and creating a whole symphony of flavors.
From sweet and nutty to even a hint of bitterness.
And just like the Maillard reaction, caramelization can happen with other ingredients too.
Right, like onions. They've got natural sugars that caramelize when you cook them low and slow.
And that's what gives them that incredible depth of flavor. Okay, so we've covered the basics. Now let's get a little fancy.
Fancy, huh? Bring it on.
Let's talk spherification.
Oh yeah, those tiny little caviar pearls that burst in your mouth.
Don't mind blown by those.
But seriously, how do they do that?
Okay, so it's all about sodium alginate.
Sodium alginate, got it.
You mix it with your liquid of choice, whether it's mango juice, balsamic vinegar, whatever you're feeling adventurous with.
And then the calcium bath.
That's the magic touch. The calcium reacts with the alginate, forming a thin gel membrane around the liquid.
Creating a perfect little sphere of flavor.
Boom. Spherification.
It's like culinary alchemy, turning liquids into tiny edible jewels.
All right, last but not least, let's revisit emulsification.
Emulsification. The art of bringing oil and water together.
Think vinaigrettes, mayonnaise, all those creamy, dreamy sauces.
But oil and water don't naturally mix, do they?
Nope. That's where emulsifiers come in.
Like mustard in a vinaigrette or egg yolks in mayonnaise.
Those little guys act as peacemakers, keeping the oil and water from separating.
So we get that smooth, stable texture.
And that's emulsification in a nutshell.
You know, all this talk about molecular gastronomy is making me realize just how much science is happening in our kitchens every day.
Right. It's like a chemistry lab disguised as a cooking space.
But there must be some downsides to all this, right?
Well, that's a good question. Some people argue that molecular gastronomy can get a little too technical, too focused on gadgets and fancy techniques.
I can see that. Like, sometimes it's nice to just keep things simple.
Right. And there's also the concern about additives and chemicals.
Yeah, I mean, while many of them are safe, some people prefer a more natural approach to cooking.
And let's not forget about accessibility. Molecular gastronomy can be expensive. Not everyone has access to specialized equipment and ingredients.
So it's not exactly the most inclusive culinary movement.
But even with those criticisms, I think there's still a lot to learn from molecular gastronomy.
It's about finding a balance, right?
Exactly. We can embrace the scientific insights and innovative techniques without losing sight of the joy and simplicity of cooking.
Maybe it's about using science to enhance our cooking, not to overcomplicate it.
Well said. So where do we go from here? Welcome back to the Deep Dive. We've been on this incredible journey through the world of molecular gastronomy.
Yeah, uncovering all those secrets hiding in our kitchens.
It's really mind-blowing when you think about all the science happening every time we cook, right?
Totally. And we've seen how understanding those chemical reactions can make us better cooks and help us appreciate food on a whole new level.
So as we wrap up, I'm wondering, how do we actually use all this knowledge? I mean, I don't have a lab in my kitchen.
You don't need one. That's the beauty of it. Molecular gastronomy isn't just for fancy restaurants with all the gadgets.
So even a regular home cook like me can apply these principles.
Absolutely. You can use this knowledge to improve your techniques and create amazing flavors, even without specialized equipment.
Okay, I like the sound of that. So, for example, knowing about the Maillard reaction can help me get a better sear on my steak.
You got it. When you understand that the reaction needs high heat, you'll know to use a hotter pan and get that delicious crust without overcooking.
And knowing about caramelization can help me avoid burning my sugar and get those amazing complex flavors in my sauces.
Exactly. It's all about controlling the heat and letting those sugar molecules transform into something truly special.
I have to admit, though, this whole science thing can feel a little intimidating in the kitchen.
I get it, but molecular gastronomy isn't about complicating things or replacing traditional methods.
It's about understanding why things work, right?
Exactly. It's about using science to boost your culinary intuition and unlock your creativity.
So it's not about throwing out grandma's cookbook. It's about maybe understanding why her recipes work so well and how we can tweak them.
That's it. It's about bridging tradition and innovation.
I love that. So as we wrap up, what's the one big takeaway you want our listeners to remember about molecular gastronomy?
I'd say the most important thing is that understanding the science of cooking can make you a more confident and creative cook.
It's about taking control of your ingredients and techniques to create amazing and memorable meals.
Whether you're a seasoned pro or just starting out, there's something here for everyone.
Well, I'm definitely feeling inspired to go experiment in my kitchen.
That's the spirit. Go have some fun and don't be afraid to get a little scientific with your cooking.
Great advice. Thanks for joining us on the deep dive, everyone. Until next time, happy cooking.
2022, I.